to me is to talk about the challenge for Salmonella control in a global industry. I just show very quickly where I come from. Here in South America, or more than 10,000 kilometers, here is Brazil. Most of our poultry production is in the southern part of Brazil, where I'm living, in this small city called Cascavel, very close to Iguaçu Falls. And here is a nice view of Iguaçu Falls. It's beautiful. If you have a chance to go and visit there. And this is the town where I'm living. It's 300,000 inhabitants, 64 years old, very young. So I'm from this part of the world. And my challenge is to talk to you in less than 20 minutes about the current challenge for Salmonella control. I would like to just point out that my talk will be more on practical point of view than really on a science, but I will use the science to answer the practical questions. And one of the reasons that we have a very, very high challenge to control Salmonella, because it's very complex. This organism has very complex epidemiology. Monitoring is associated with cost. That's a vision of sometimes the producers. And then a high requirement by the legislation and the consumers. So it requires really a lot of effort from the industry. And absence of products or programs that they are very effective. We have a lot of products that are effective, but not very high effective. And a lack of knowledge. So I will try to review a little bit of this, going through the disease, and to point out those factors that I think affect the control of Salmonella worldwide. For this talk, very quickly, we have this amount of more than 2,600 different Salmonella. We're going to separate them into two groups. The Paratyphoid, where it is more than 2,600 Salmonella. Fortunately, only 10% of them affect poultry. And the main concern is human health. Bird health is not really concerned with this group. But the group that really concerns us with bird health are the typhoid group, then Salmonella gallinaria and Salmonella pullorum. And I'm going to jump between them one and the other and showing my view on the challenge. Here are some aspects that I feel that are very important, just for us to keep in mind, regarding to some characteristics, like the typhoid group, Salmonella gallinaria and pullorum. The problem is a bird health. Paratyphoid, it is not. Human health is the opposite. So here is our main concern, human health, not bird health. Performance, the Paratyphoid group basically do not affect performance. That's not a big question, only occasionally. Legislation worldwide is different in the different countries, but in general, there is legislation for both Salmonella. The market for both are concerned. There is a concern for selling the birds regarding to the Salmonella infection. And the vertical transmission, that is very important. For the typhoid group, it is there. That's a concern. But it's very important to keep that in mind for the control that we look. The outbreak frequency of Salmonella, global overview, is that for pullorum disease, it is rare or occasionally. This will depend on countries. There is some country has, the incidence is higher, or there is lower. A few ones they do not have, but in general, that's a general view. And the fall typhoid, then that's occasionally, or sometimes it's frequent. And most of my focus is meat type of chicken. If it is eggs, works a little different because the biosecurity to eggs and is a little different. Then the Paratyphoid Salmonella. This is the group that's giving us nowadays the more concern. And then we have frequent. We can find frequently, and in most of the place also is endemic. And here, just very, very quickly, try to show you countries like here, Canada, US, maybe like Brazil, Chile, Argentina, Colombia, a few ones. For Salmonella typhoid and gallinaria and pullorum, they are under control. With a little bit, some break once in a while, they're under control. Less control we have in Africa, and a good control, let's say, in these countries, in the Norwegian, Sweden, and Finland, and Denmark. Probably they have a very, very good control. They're free of this Salmonella. And China, there's a lot of this Salmonella, and some India, some other countries, but like Japan, they have under control the Salmonella typhoid. If we talk about the Paratyphoid group, then is a different. Then we can, it is spread all over the world. all over the poultry population, with some degree, difference in some degree, but it's all over the world. With exception, this country, again, that really they have a small bird population, and they have under control. So that's the overview. The typhoid, the main concern, why we need the control? Because of mortality, performance. Then we have to attend legislation and market requirements. So, but for the paratyphoid, the main concern is health, public health. And also we have attend legislation and some market requirement. And here are some characteristics that I feel very important, and unfortunately I have time to go through in details. But we have to understand those characteristics if we want to control. Otherwise, it will be very complex to control. For Gallinarum pulorum, they are limited in distribution in the poultry industry, mainly in backyard chickens and some in commercials. They survive weeks and months. In animal, they infect only poultry, and that is a good point. They are vertical transmit, and they cause clinical disease with a high mortality. That organized poultry industry cannot survive with a pathogen like that. There is only 2 serotypes that really matters for us. And the behavior epidemiology is all over the world, basic is the same. So there's the characteristics for the Gallinarum pulorum. They are moderately resistant in the environment. They are sensitive to disinfectant, fermentation, pelletization, pasteurization, and antibiotics in some degrees. And for the vaccine, they respond according to the characteristics of the vaccine. It's some partial response also to Salmonella enteritis vaccine, some cross protection. So that's for Salmonella typhoid. And here are some birds that are being affected with Salmonella typhoid. With Salmonella gallinaris, it's easy to see because the birds die. Very easy. And we see drop in egg production, we see large spleen, large liver. So it is very easy on macroscopically to identify an outbreak. Pulorum is a little different. Maybe we don't see, maybe the birds behaves normal, minor drop, but we can recover the Salmonella, so we have to do some monitoring. But if the poultry hatch, then we'll see. This is a clinical sign. If we do not intervene on antibiotic, there's high mortality. So that's somehow easy to observe in the field. Occasionally, we see some invasion in the blood system that goes to the brain and cause some kind of encephalitis. We have a recovered pure Salmonella for the brain. It's not too many cases, but occasionally we find some cases with Salmonella. Also Gallinarum and pulorum. And some lesions in the heart, sometimes we see this only in the processing plant, but we can find related to the typhoid infection, and also some joint problems. And just I point out here to make a difference from Mycoplasma synovium and real virus, the edema is more homogeneous. And when we have this break with Salmonella, then we have more like a nodules, like more localized. But occasionally we can see this disease. Then the paratyphoid is the opposite. Birds are looking healthy and high production, and there is no problem. And that's one problem. In the environment, the paratyphoid Salmonella spp, they are widely distributed, survive weeks and months. And they can infect all animals and remain healthy but carrier. It can distribute the Salmonella. There is more than 200,000, 2,600 serotypes. Fortunately, only 10% of them infect birds, but 10% is more than 200, 300. Salmonella has been isolated from poultry. They do not cause disease. Occasionally, Salmonella enteritis the Typhimurium, but very mild. And that's a good part, but it's difficult a little bit to identify the break. They are resistant in the environment, but they are sensitive to disinfectants in general, fermentation, pelletized food, feed, and pasteurization and antibiotics. They respond to vaccines, but to specific vaccines. It's not to, because sometimes we vaccinate for Salmonella enteritis, and you want to protect against Salmonella Typhimurium. It doesn't happen like that. So that's one of the limitations. And now we are having some breaks of Salmonella Heidelberg. We try some vaccines in Brazil, and we're not getting the best result or the results that we'd like to have. So where are the sources of this Salmonella? It is important to understand. If we can summarize, the 3 sources for Salmonella are the day-old chick, the bird, in the environment, and the feed. But look where we can find them. Really in the transport, in backyard chicken, rodents, equipment, man, and hatcheries, slaughterhouse. So it is widespread. That makes very difficult to control the Salmonella. And this represents here the Paratyphoid where we can get the infection. So many sources, and that makes it difficult to control because each one of these has to be controlled. If it's Salmonella gallinarum pulorum, then the control is a little bit easier because it's backyard chicken are the main source, eventually layers, and also meat type of chicken transmitted to meat type of chicken. But basically, the backyard chicken are our reservoir, and that needs to be our focus. It becomes from infected bird, but it's infected bird, not other sources. The other source can come just by carrier. So backyard chickens, and then look in the gut, the paratyphoid, last part of the gut in the fecal material. If we look gallinarum pulorum, we have to focus on the liver and spleen. And that is important for diagnostic and monitoring. So the paratyphoid, we have a variety of source for monitoring, and also other animals in the property, so can be the source. And also here, I just want to point out that sometimes, look this house here, there's 500 meters here. Because there is low level of elimination of a Salmonella, sometimes this house can be positive. If there is no people that make the connection, this one can be positive or the negative. It spreads very slowly for Salmonella paratyphoid by aerosol. And a situation like this is a little different because there's too crowded. For the diagnostic, two things that I want to point out about the diagnostic. If we look for paratyphoid, look the different source where we can go. In the farm, then the litters, feces, in the feed mill, the dust, meat mill, soya, slaughterhouse, meat mechanically separated carcasses and the crates, in the breeders, in the hatchery. But if we look for typhoid, it's just organs and serum of the birds. So then change for diagnostic, we have to keep this in mind, because that is one of the mistakes that we frequently see. And then for isolation, also the lab has to know that you are suspecting, because there is a kind of a quick way to isolate. We can, if it is typhoid, we can just go to enrichment media or plates, in a grow plate, and then biochemistry serology. In 2 to 4 days, even using, let's say, the old technology, it is possible to isolate. So from the organs that we suspect, go to the media or direct to the plate, and next day to biochemical, then serotyping, and you can come out with diagnostic very quickly. But if it is paratyphoid, then it takes longer. It takes 4 to 10 days. The steps are longer. I'm not talking here about molecular biology, that it is available, but not everywhere. And maybe in the future, those things we'll forget and use more like molecular biology type. But that makes it difficult. We have to go through all these steps for the conventional way, for the paratyphoid. This is to show you, we have done in our lab 2015, 5,607 serotyping of Salmonella. We found 121 different serotype of Salmonella from poultry. So we have a variety of serotypes. 48 serotypes showed just once. It is important to serotype the Salmonella, because that information, we don't need to go through these serotypes here, because they just show once and disappear. And Salmonella enteritis in our situation is going down. In the past we had a lot, now it's down. Salmonella typhimurium, look what's happening with Salmonella Ileberg. That is a southern part of Brazil. We are having something unique, and is why it is important to serotype and to understand each serotype that you are having in your farm or in your plant or operation. They are not equal. Here is just a chart to show you, like Salmonella Heidelberg, there was not present 2010 in the area that I'm living, and then suddenly appeared, it is very severe. And typhimurium is slowing down. Enteritis, because we introduced the vaccine in 2003, 2004, it went down, we were a very, very low number. But other Salmonella maintains equal, but some others like go up a little bit, like Munchkin, go up a little bit. So we have to build tables like this to understand what is going on in our farms. And this is important, just the survival of Salmonella. We put in corn, grits, and then soybean. And we gave the Salmonella M. bandaca fixed amount in all of them, you'll see that in corn doesn't survive very well. But in soybean, it can survive even 4 months. So it is important to know that, to consider that on a program of control. That was experimental that we have done. And now Salmonella, a new challenge that we are facing. We had some breaks in the past, but it was from grandparents to breeders to broilers. And from 2011, it started to show up only in broilers. And at this point of Brazil, where we are located, and then in a few years, kind of spread. Now we have this in the different states. And it's becoming, look, the antibiotic resistant, we tested for this 12 antibiotics. In the beginning, they were very sensitive, a few ones resistant. And now they are becoming a lot of resistant. The use of antibiotics is not too much to treat the Salmonella, but it's used for other purpose. And the Salmonella becomes very resistant. And then on molecular biology, we found that our strain is a little different too. And look the difference. We challenge birds, we 10 to the 5, a third day of the age, and then we check 7 days later and 14 days later. Each bird, we count them. For Salmonella enteritis, went up 7 days and 14 days down. Look for Salmonella Heidelberg. It behaves totally different. It multiplies in a high number. And that makes difficult the control of Salmonella. So we have to consider which strain, which serotype we are working with this. And so what is the difference? Highly adapted to the environment. We don't find in the feed Salmonella Heidelberg, we don't find in the breeders. And we have done thousands of samples on this Salmonella. So this is a different serotype. And if we don't know that, we put our effort in a wrong place. Absent in breeders and feed, limited response to treatment, very high resistant antibiotic, and now we are testing with the vaccine, but we don't have too much hope on the vaccine, unless we develop a vaccine specific for Salmonella Heidelberg. Just to show you what we had in Brazil, in 2007, 50% of all our breeder flock were positive for Salmonella, and now it's 1%. I'm talking about specifically enteritis. The vaccine has worked very well, but this is because it's transmitted vertically. And for other Salmonella, maybe it is not vertically, the vaccine was not going to work as well as for Salmonella enteritis. The monitoring Salmonella typhoid and paratyphoid, the characteristics, the paratyphoid, there is no clinical signs, no change on performance, low number of infected birds in a flock, and intermittent shedding. So this is very important. So we have to monitor. We have to get samples and work with samples and more samples and samples to get really hands on what is going on. So all this needs to be monitored. It's very complex. Difference diagnostic between the typhoid and paratyphoid. The typhoid, it is in the chicken or turkeys, we'll culture liver, spleen, ovary. So the typhoid is very limited. It's strict direct on plates, very simple. And also we can use serology if we do not vaccinate. But paratyphoid, then animals, environment, feed, equipment, carcass, and the results a little bit longer. And there is no serology available, very, very limited. So it becomes complex. We found the paratyphoid in different sources, so that becomes very difficult to control them. This is a nice... we didn't set this experiment for, we set this experiment for other purpose, but gave us a nice answer for us. We put in the same square meters, we challenged the third day with a fixed number of a Salmonella, same number, but one of the pens, in several pens we had 8 birds, and other pens we had 20 birds. And look what we recovered Salmonella. So density of the birds makes big difference. Higher the density facilitates for the Salmonella presence. So that explains sometimes why products works in one region, doesn't work in another region, and because we are using 12 birds per square meter, 14 birds per square meter, 16 birds per square meter, and this makes a lot of difference. Control and prevention will be very quickly. We have the American model, pre-harvesting, the focus, and European model, post-harvesting. Here we use more products in the slaughterhouse. Here is very limited, so if we could mix both, would be the ideal. But it depends on the decision of the country. To control, actually we have a lot of products. Look, we have Antibiotics, organic acid, herbal extract, oil, essential oil, a lot of, including vaccines. All of them, some of them works better than others. They have some contribution. But unfortunately, we don't have a single product that really give us a good control. So we have to have a knowledge of each one, how it works and how it prevents the disease. But we have to focus on biosecurity, cleaning, disinfection, downtime, and birds density and litter quality, humidity. There are several of things that we have taken into account. Some products, and then management and biosecurity and integrate program. Our experience is we have to have someone that managed information from slaughterhouse, from hatchery, from breeders, because sometimes there is company that they do this separately. And we have to sit together at least once a month and digest those data and procedure what is working and what is not working. So this is the last slide, Mr. Chairman. In summary, I try to show you very quickly the complex epidemiology, the nature of Salmonella. That makes it difficult to control Salmonella. It's not an easy task. Monitoring sometimes is considered as a cost. And then we start to monitor to get some data, and then we stop. So we have to have data, have information. High demand by legislation and consumers. That is real. It's very difficult to produce Salmonella-free. It's not an easy task, but some countries, they buy and they want only if it is free. So there is a lot of effort on this and needs a lot of investment. Absence of programs or products 100% effective, that's our difficulty. And I think most of the time, there is a lack of knowledge about Salmonella. I tried very quickly to give you some brief information that I think is important. There is so many others that are important. I think maybe I mixed things. I made your mind like that, okay? But that's the Salmonella, okay? But don't worry. Life is not always like that. There is a light at the end of the tunnel. So there is some solution. And I like this, like you guys, we like science. And look, if we look in the nature, we saw this get a hide here. We have done the same. We observed those birds has, this minor changes here. And we have done the same, and that has reduced 1% of fuel consumption. Just to put the tip of the wing like this. It reduced the fuel consumption. Maybe look in the nature, we'll come out with some solution for Salmonella, because it's not been easy. But since we don't have the right solution so far, okay, let's rest and enjoy a little bit. Thank you very much.
Thank you, Dr. Back, for a very interesting presentation. Now it's time for question and answer. Can we have the first question, please? Okay, I have a question. Salmonella is a very ubiquitous organism. And it's found everywhere. It's so difficult to eliminate. And in Asia, various feed additives are used besides vaccines in an attempt to control Salmonella. And in your opinion, Dr. Back, which feed additive is most suitable in a strategy for Salmonella control and elimination? Is it acidifiers or probiotics? I've seen big accounts using both.
Talk to the microphone, otherwise
Okay.
Okay. Well, which products do you have available, or if you have acidifiers or some probiotics and so on? Which one is working? Which should I suggest for you guys? My experience is like this. First of all, you have to identify each Salmonella you have. Which one? Because they behave different. They behave differently. Remember the situation with the Salmonella Heidelberg? We are not finding the feed. We are not finding the breeders. We're just finding the environment. And for that one, so vaccinate the breeders probably has no benefit. To include some products in the feed, you have to select very well the product, because maybe we're not going to see the benefit. So the first thing is try to understand, identify which Salmonella we have. And then look in the market. We have found products that doesn't make any help on controlling Salmonella, on reducing Salmonella. There's some product even makes worse. And there is a lot of products in the market that give some benefits. So we have to test. My suggestion, It's just to test the product, to know which Salmonella you have, to test the product, because they behave different. Sometimes environment, sometimes there is some variables that are different in different areas. But yeah, there is probiotic that works, they reduce very well. Some organic acid can be helpful. So there is a lot of products that can be used.
Thank you, Dr. Back. Any more questions?
Thank you. My question is how to make the difference between field strain and the vaccine strain.
Wow. You have to talk with your manufacturer, because when they release a strain in the field as a vaccine, for sure they have a way to identify. And there is some markers. If you go, for each vaccine must have a marker. So it depends on the manufacturer. It can be through antibiotics. Yes, there is some that can be identified. And I'm sure that soon we'll have some molecular way to identify. And for Salmonella gallinarum pylori, the 9R strain, yeah, that can be identified by culture. That's possible because it's a rough strain. But we have to go through the manufacturer and try to get the information from them. For each one that is in the market, there is a way to identify.
Okay, any more questions? One last one, yes?
The increase in Salmonella Heidelberg in Brazil was almost exponential in the last few years. And it was also interesting to see the increase in antibiotic resistance in that strain. Do you have any theories on why this increase has occurred, and is there a management practice or the use of antibiotics that may have been part of that?
You are saying Salmonella Heidelberg or in general Salmonella?
No, the Salmonella Heidelberg, 44%.
Heidelberg, okay.
Yeah. So
yeah.
What if it's not in feed or breeders? What's your theory on why it?
I have a theory, at least a theory. It is some molecular change. We do not know minor details on that, but it behaves different. It behaves different. So I think there was some change, some mutation, some alteration in the DNA. And I think it's the main characteristic that makes hard to clean Salmonella Heidelberg in Brazil is the fact that it multiplies in very high number, then it spread in the environment. Even if you do a good cleaning, a good disinfection, you cannot reach 100% of them. And they survive in environment very well. There is colleagues of us that has took sample, even the crop that is in the side of the houses, 100 meters out of the houses, they can get in the soil, can get the Salmonella. So it survives, and we spread the litter and all these things. For Salmonella Heidelberg, I think is a mutation, or this strain is a little different than the old ones, because the old ones came from grandparents to breeders to broilers. We eliminate in the grandparents, in the breeders, it was eliminated in the broilers. But this one, no, it is not in grandparents, it is not in the breeders, but is well adapted to the environment. So there was some change. And maybe we're getting more Salmonella in Brazil, and it's because we are looking for Salmonella. If we don't look, we don't find. But if we look, we'll find.
Okay, thank you very much, Dr. Back.
You're welcome.